Okay, self, this is the video for week 7, which was measures of association. So the Excel, the example the professor gave us was this. Basically, our job was to take a look, to use the survey data and explore bivariate relationships between the following variable pairs. So we pull these pairs from the data set. And then he put, if you look here, he put these things in order for A, B, C, D. That wasn't exactly what we needed to do. His assignment actually said something different. It said create a scatter plot, which is actually B on the paper. Determine the correlation coefficient, which is actually C on the paper. And then determine the p-value for the correlation coefficient. Okay, again, just a reminder, we always want to look at our p-value because our p-value is the probability that the result we got was due to chance. So even though he puts that as the last thing to do, that's actually the first thing we should look at, simply because if we have a high p-value, there's kind of no point to even look at the rest of it because it wouldn't help us. Anyway, so basically, we pulled the data. Here's the data set, okay, and we pulled the data and we put them side by side. There's a couple ways to do this. So the first way was we could create individual, if you highlight here, we could create individual correlation coefficients. So we go down, we highlight. Even though it goes past 273, he told us to only go up to 273 just because there's missing values. So we went to 273. We go to data analysis. We go to correlation. We hit OK. Let me get to my paper. We go to input range. Okay, we click where we want. Go back to our arrow. Oh wait, I did that wrong. Hold on. Cancel. Highlight. Okay, we go to data analysis. We go to correlation. We go to input range. Then we go up and we highlight. So the first two, bureaucratic culture and red level, go down till we hit 27. Oh, we went too far. Hold on. Okay, we go to 273. Arrow down again. Highlight two column. Okay, we check labels because that's what we did. We do output range, and we click where we want it, and then we hit OK. And there we are. So we basically have the same number we got up there, except this one's more elongated. Okay, the way we got this big table here is we just highlighted all of them, and it popped out. To explain, so we could either do one of two things. We could do just the two different ones, the two different columns that we're comparing, or we could do all at the same time. This gets wonky though, because if you look, like, all right, so let's say we're looking at group and we're comparing group culture and bureaucratic. You have to make sure you're matching what you want. So what I did is I highlighted it. So we know we're comparing red level and bureaucratic culture. We know we're comparing group culture and job satisfaction. And we know we're comparing communication and central whatever one stands for. So I went ahead and I just highlighted the numbers to make it easy. Okay, then we have to create a scatter plot. That's pretty easy. Let me delete this. Let me really delete this. Okay. All right, to create the scatter plot was pretty easy. Basically, you highlight the two columns that you want to create the scatter plot for. So we're going to do central and inner column just because it's right there. Okay, go back to 273. Okay. We go to insert. We go to scatter, and you just pick a scatter plot. And there we are. Just to point out, what did it do? Okay, the scatter plot's going to look weird, and the reason it's going to look weird is, why is it doing that? Hold on. Central 1. Okay. So the way I labeled the first scatter plot was A and B, and A and B correlated to column A and column B. So the scatter plot I just created down on the page would actually be E and F. Let me just make sure I did that all right, because it looks weird. Looks very weird. All these scatter plots looked weird, and he said that that was fine. I just want to make sure that it is fine, that I just didn't click the wrong thing. Okay, go back to 273. We go to Insert, Scatter. Yeah, I guess that's it. Let's delete that one. Okay, so one thing a classmate pointed out, so if we're trying to figure out which one's X and which one's Y, we look at the highest value. The way we can quickly look for the highest value is, let's say we want to figure out whether intcom1 is the dependent or the independent variable according to how the scatter plot was formulated by Excel. The way we do that, one way to do that, is to filter so we can have an idea of our results. I didn't need to highlight it. Hold on. Filter, cells value. We want to do from largest to smallest. Why did it just do that to me? I don't know why it just did that to me. I'm trying to think why it just did that to me. Anyway, we look for the highest value. So intcom1, I'm only seeing 4. There's 5. Okay. There's 5 again. 5 again. Five again. So it looks like intcom1 has the highest value of 5. And I'm looking at central and I'm not seeing a 5. So we know because intcom went up to 5. This is intcom here. It's the dependent. And this is the independent. So intcom is our dependent because the highest value went up to is 5. But the highest value central went up to is 4. So central, which is on the x-axis, would be our independent variable, and intcom1 would be our dependent variable. It's on the y-axis. So we know that as, if a positive relationship is that as central 1 goes up, intcom, our y-axis, would also go up. So this looks pretty much like a positive relationship. If it was negative, as central went up, y would come down. Okay? So that's one way to look at it. Let's delete that. We don't need it. Okay, so the assignment required us to do a formula. The formula is right there. It's also on the sheet, on the example sheet that he gave us. I'm not really going to go over that. It's pretty self-explanatory how you calculate it. Also the p-value. The thing is with this funny number here with an e, that basically stands for an exponent, meaning it's an extremely small number. We go back to here. The only thing I want to point out is for some of these negative numbers, when we were trying to, in class, we were trying to calculate the p-value for intcom and central, we actually had to take the negative sign out because the formula wouldn't work without it. Apparently the professor said that that made sense because when you times things together, you square root them, it takes the negative out anyway. So we took it out. And so that's the only thing to really note is if you get a negative number, this formula may not work up here. Okay. Basically, rule of thumb, you know, so again, we're looking at our t. Our t is in the tails. It's a pretty big number. We want our p-value to be small. Again, t and p are opposite. And that's how we figure this out. So let's look at the instructions again. Create a scatter plot. So B is actually, we need to do a verbal look to see the relationship. Is it a positive or negative relationship? As far as C, the correlation coefficients for each pair, we treat that pretty much like a t-value anyway, and determine the p-value, same thing as probability. So it's pretty simple, just follow the formulas and that should be it. All right.